Hey, hello everyone. So yeah, it's time to simulate. So inside our network, we have this setup here. So actually we can delete this one. So first of all, we will start with the ground plane. So because this is the easiest part, okay? So this is a node ground plane and we have a merge here just just in case we have to add more static objects. And then we're going to create the gravity node, okay? And everything is going to point into our out. So then we import our stuff. So first we import our ball. This is an RBD pack object, and here we can put the path of our null. That's why it's important to create nulls. Or if you want in the geometry source, you can say like, okay, first input, second input. So the bullet data is an important stuff you should know. So uncheck the display geometry and check the show guide geometry. So the blue part is gonna be what Houdini is computing. So check it out, because sometimes the blue part is not correct. So you have to readjust. And the RBD pack object of the wall, here we have the same. If we go to the bullet data, we import our wall. So cool. As you can see, for Houdini, it's much easier to generate this show guide geometry with the convex decomposition, because this is convex hull. So if we had the high resolution pieces, we should work on concave. But this, trust me, this takes a long time and it generates a lot of errors and it's a mess. I hate. So inside these nodes, there is a tricky part that I always forgot, but you should do it. So if you go to the physical tab, there is a density option. So if we are working with concrete, we should like increase this number. So I mean, it's logic, right? But I always forgot to put these parameters. Remember that you could like say, okay, first input, second input, third input, okay? So, and we're gonna do the same with the ball, because it's a wrecking ball, but 1000 I think is okay. Remember, this is like you have to test and try, okay? And then we add this with a merge. So then I like to work with the multi-solver. The multi-solver, I think it's cool, because if you want to create another bullet RBD solver, or you want to create another different solver, you can plug it in the multi-solver. So it's kind of cool when you have more simulations in one project. So that's cool. So we don't have to touch anything in these two nodes. By default they work. And this is the constraint section. So we have three constraints. This one is for the wrecking ball. And these two ones are for the wall. So the soft is gonna like do like the blending or creating like a resistance of the wall, and the glue is like, okay, is the simple one, is the simplest one. So first, let's create a constraint network for our wrecking ball. So here we are gonna input our out wire, that if we remember is this one that we created, okay? This constraint, this line, okay? So we put this path into the constraint network. So that's cool. And then we're gonna create a bullet soft constraint relationship. Yeah, I know, it's like a short name, right? And here we are gonna import only the name that we created in the constraint name. Remember that we created with the attribute create, or the name that we put in the attribute wrangle. So you have to put it here. This is the expression like $OS. This is gonna take the name of the node, like the up digits, but it's gonna take this. You can delete it if you want. I mean, we're gonna put in this name, remember. If you put another name, it's not gonna work. So remember, it has to be the same name. So once with this, Houdini is gonna input our constraints properly, and we only have to play with the stiffness actually, because the other ones is gonna be like a mess. And the rest length, we already have it. So just put one because we want the same. So then we have the constraints for the wall. So let's start for the soft constraint. Okay. So basically, this is the third context geometry. Remember, because this soft is getting inside the third one. Okay. And in the bullet soft constraint relationship, we are putting the same name that we put in the attribute wrangle. So that one, that's perfect. And remember that the expression we have the $OS is like taking the name of that node. Here is just like guide options to visualize better the constraints. So the constraints now are working, but the problem is that they are not gonna break never. So that's why we create the subsolver. So the third input, it's always for the subsolver. This subsolver is a little bit abstract, but basically is taking this context that we have here, and it's like showing us in this part, but inside the DOP, okay? So basically it's like we are working in the sub, but inside the DOP, okay? I mean, yeah, it's not very easy to understand, but you will manage. So here we create this primitive bob, because remember that the constraints are primitives, and basically we are taking the input, the data from the op input 1, and we are taking the other one and we are comparing. So if it's bigger, we are gonna like, here we will see like in a color, but this is only for visualization. And then we're gonna take this information, this data, and we're gonna create a bind export, and we are gonna put the name force color. You can put the name you want. And this parameter, we promote this parameter. If you click middle mouse and you put the promote parameter, you will have here this test force. So in the slider, you will be able to control. So now it apparently it doesn't show anything, but the constraint is here because it's dark. But if we change to light background, we will see something. So if we now press play, we will see that when the ball is like colliding with the wall, we are having colors. That's cool, because the get attribute force is like using the force attribute that it's already in Houdini. Okay, so we are basically comparing. So if the force is bigger than something, paint it in color. So playing with this slider, you will have more or less, okay? So cool. Once with this, we create an attribute promote. Basically, we're taking the CD and we are going from primitive to points, okay? You can skip this, but I mean, I think it's cool to have it in points. And here in the delete, we're gonna put delete by expression, and we're gonna say like, okay, if the attribute color diffuse is bigger than 0.001, let's delete the primitives. So cool. If we press play, we will see that boom, we are deleting constraints. So if we are deleting constraints, we are deleting the relationship. So the pieces are gonna like go by their self. Okay, we can make a test. Okay, we can check this, and it's working because apparently everything is like falling down, but as you can see, the constraints, the lines, the white lines, is like they are working. Okay, but in the points that we deleted, they are like not connected. So let's switch. Let's explain the glue constraint part. So this is like easier. So let's put for context geometry, and here let's put the name of the attribute wrangle we created before. And here you only have to play with the strength. If you want like ultra strength, like never breaks, just put -1. And inside the subsolver, there is another workflow. We only create an attribute wrangle in primitives, and we put the expression, the conditional of if the impact, which is data that we have, it's bigger than 100, you can check these numbers in the spreadsheet. So we are going to use the expression remove prim to delete the primitives. Cool. If we check the result, boom, we're going to see that it's working. At some point, some pieces are like losing their constraint and they are falling down, and that's cool. And some of the pieces, when they touch the ground, it's like they are losing their constraint. As you can see here, there is a small piece that is like creating like errors here, but remember that then you can delete that piece and nobody's gonna notice. So as you can see, the calculation is so fast. I mean, we are quite close to real time. So we have a lot of pieces. And my computer is not like a super machine. It's like something normal. Cool. So with this, we have our simulation. So now we have this star that is like exporting all the elements. But you should know that it's better to export the elements like with the DOP imports. So here you have the DOP import and the DOP IO, which is the same, but I'm going to show you both. So here we just put the DOP network we want to use, and then we put the wall. The wall is like the RBD pack object that we want to export. So this is the wall. And now if we press play, we'll see that we have the same simulation of the wall without the colliders or anything, or the ground. And in the other side, we have the collider, the sphere, or that we have it here. Cool. So in this DOP IO is like, okay, which DOP are we using? And then just the path of the ball. And remember to put like the no change. So add 1 and put no change. Because this is more for pyro exportations, but it's working. So cool. See ya.